Now, there are likely to be more control LoRa's coming through in the next few weeks, but the original control LoRa's were ControlNets, and ControlNets can be used in a very similar way. In fact, I used a ControlNet with the workflow that we used for the control LoRa for the Canny control LoRa, and this was the result that I got using the first ControlNet that has been introduced for SDXL. This is in comparison the control LoRa, the 128 rank control LoRa from Stability AI. So there's quite a lot of difference between the two. And I would say for this particular render, I think the control LoRa actually won a little bit. The original image is this image here that we are looking at. It's a fairly nice 1024 by 1024 image. And I think what we want to do with this one is to take a look at how we can get better results, maybe even than this, using the control LoRa. The ControlNet. Now, the ControlNets themselves were first introduced in February of this year, and they were introduced following a research at Stanford University. The research paper is one which is fairly interesting to look at, and having done that, I can show you the original concept. So we've got the canny edge detection here, which is one that we've looked at for the control LoRa's, and we're going to be looking at for the ControlNets. And you can see the basic idea how you can control certain aspects of the image using the original image. Now, I want to take a look at other ways that you can use ControlNets because they're very well presented inside of this paper. So there are more examples of the canny edge and how it can be used to generate different types of images. And here we've got results working with automatic prompts and user prompts. And you can see it. Oh, I really like this one and that one. And you can see the cute kittens there. Some variations based on the prompts, but the basic composition remaining the same. So this is really about retaining compositional elements. And we can see here also that you can use images that have been created inside of Stable Diffusion or other AI images to create these sorts of variations. But the paper doesn't stop there. It shows us how line inputs can be used to create variations. And further down, we can see other uses of basic scribbles to create these sorts of variations. And it's fairly impressive the amount of research that went into this. A very simple elephant scribble produces these variations here. Now, this sort of research has been going on for quite some time, and quite a lot of what we're doing basically is built on this type of research. But it's interesting to see how you can sometimes get layers and layers of research kind of coming together in a single project, which certainly is what seems to have happened here. So there's a type of input known as the HED edge. Another one is a pose. So we've got these women posing according to this kind of stick figure, and more posing. So all of this is basically what's possible with the ControlNets. The posing here is coming from a Michael Jackson's concert. Nice to see the king strutting his stuff in AI. And we've also got some really basic stuff. This kind of stuff, I think this might be called segmentation. You'd have to correct me on that if I'm wrong, but you can see basic colors coming through as impressive images. And what the researchers are saying, so this is cocoa segmentation coming through as a bear. So this kind of research has been done by several researchers over time, NVIDIA, these guys at Stanford University. And interestingly, they compare their technique. I think this is a technique which was developed by Stability AI. And we can see how their technique actually compares the benefits and the disadvantages. So quite a lot of stuff here, which if you're more research oriented, you probably want to take a look at this paper. What we want to do, however, is to look at the practicalities of using ControlNets. And one thing I wanted to mention with the ControlNets for some of the more advanced users out there is that they do mention just how easy it is to train a ControlNet. So they say training a control net is as fast as fine-tuning a diffusion model. So if you want to get a little bit more sophisticated or advanced, it should be possible to create your own control nets. But in future, it may be possible also to create your own control LoRa's, which can be derived from control nets. Now, the first control net for SDXL came out a couple of weeks ago. And if you want to download that one, it is called, is I think actually published by Hugging Face. It's called ControlNet Canny SDXL 1-1.0. So this one is the one you download. I'll have a link to this particular page. And there are a number of options they've got here. So the one I'll be using, I think, is going to be the Safe Tensor 5GB one, or it might be the Pickle 5GB one. One of those two. And you can, if you want to, download the 2.5GB versions of these ones. Now, I've heard some feedback from different users. Not everyone is getting success with smaller ones. So the larger ones, I've not had anything but success with those larger ones. The project itself contains quite a lot of information about how the control net can be used, but we'll cover the basic use patterns in this video or in following videos. And I'll give you some files that you can use to set up your own control nets and get some pretty decent results. Now, conceptually, control nets are very similar to control LoRa's. And if you haven't watched the videos on control LoRa's, I would recommend that you watch those first, working with control LoRa's, because everything that we need to do for the control nets needs to be understood from the videos inside of the control LoRa's. It's the same process. You need to download the same extensions, and we'll show you in the next video how to actually put everything together.